Hi, I'm Martin, and today I'm talking about carbodiphosphoranes and some of the concepts we assign atoms in molecules. To begin, the carbodiphosphoranes are molecules within the carbone family. Carbones are compounds where a carbon is bound to two other ligands, but where the ligands formally provide both electrons for the bond. Such a bond is called a dative bond. These types of bonds are often drawn using arrows to indicate which atom formally donates the electrons to the bond. Carbodiphosphoranes are molecules in which the donating atoms are phosphines. A carbon compound where only one non-metal atom bonds datively is called an ylid. Since carbodiphosphoranes are bonded twice datively, they're kind of double ylids. And since the carbon atoms formally provide none of the electrons for the bonding, they keep their 4 electrons as 2 lone pairs. Effectively, the carbon atoms end up with a -2 formal charge, while both of the phosphorus atoms are +1. A good example of a carbodiphosphoran is hexaphenyl carbodiphosphoran, which is an analog to the triphenylphosphonium Wittig reagent. Due to their 2 lone pairs, the carbodiphosphoranes are very basic, and they can be used as catalysts in some organic reactions. The 4 interrelated concepts that I'm going to talk about today are formal charge, oxidation state, coordination number, and finally valence. These 4 concepts are numbers that we assign atoms in molecules, and they are sometimes confused and consequently misused. Formal charge I have already mentioned in this video. The formal charge of an atom is considering a hypothetical. If the atom's bonds are broken and split evenly, then what would the charge be on the atom? Oxidation state is considering the same hypothetical, but with a more electronegative atom taking both electrons from the bond. If 2 of the same atoms are bound to each other, then we disregard that bond. Coordination number is simply the number of atoms bonded to the atom in question. This is often equal to the valence and sometimes confused for it as well, but they are not always the same, such as in carbodiphosphoranes. Finally, valence is defined as the number of electrons an atom uses in bonding. This can, however, be a bit confusing in certain cases, especially when the formal charge of an atom is non-zero. Let's compare the carbodiphosphoranes to another class of compounds, the carbenes. In both cases, the carbon atom is bound to 2 ligands, so one could think they are both divalent. This is incorrect. The carbenes are, but the carbodiphosphoranes are not. This is because formally, none of the electrons binding the carbon and the phosphorus atoms originate from the carbon atom. An easy way to remember the valence for any given atom is that the valence equals the number of bonds plus the formal charge.